Hello, everyone. Today, we will cover the last section of Chapter 1, which focuses on blockchain application scenarios. Globally, blockchain has seen widespread application. Bitcoin, as a representative example, has a global ledger with a market value of $145.7 billion and over 20 million wallets. Ethereum, as a global computer, has around 30 million addresses. In terms of industry applications, blockchain technology can be divided into 3 layers, spanning more than 10 vertical sectors. These 3 layers are the underlying technology and infrastructure layer, the general applications and technology extension layer, and the vertical industry application layer. The underlying technology and infrastructure layer primarily includes the basic protocols and blockchain-related hardware. Among these, the basic protocols present key technical challenges for many projects and are the primary investment focus for investors. The general applications and technology extension layer provides services, interfaces, and technical support to the vertical industry application layer. The vertical industry application layer already encompasses over 10 different industry applications utilizing blockchain technology. Let's first explore the underlying technology and infrastructure layer. This layer includes basic protocols, anonymity technology, and hardware. Basic protocols involve network programming, distributed algorithms, cryptographic signatures, and data storage technologies. These are the fundamental, underlying technologies related to data. Anonymity technology uses solutions such as coin shuffling, blind signatures, stealth addresses, ring signatures, and zero-knowledge proofs to protect user privacy and prevent the leakage of transaction information. Hardware provides the computational power necessary for blockchain mining. The general applications and technology extension layer mainly consists of fast computing, smart contracts, information security, and data services. In terms of fast computing, optimizations are made to the underlying blockchain to solve inherent issues and improve its computational speed. Smart contracts are executed automatically when specific conditions are met. For example, securities can be transferred automatically, or payments can be processed automatically. Information security is an intrinsic attribute of blockchain, effectively ensuring the security of individual and enterprise transaction data, as well as intangible assets. The scope of data services is quite broad, including services such as data sharing, databases, data protection, and more. Additionally, the general applications and technology extension layer also encompasses blockchain as a service, BaaS, blockchain solutions, mining services, and platform-level anti-counterfeiting and traceability projects. A prominent feature in this general layer is the anti-counterfeiting and traceability projects, which are typically based on blockchain, the Internet of Things, IoT, and related technologies. These projects are designed to verify the authenticity of goods and address issues related to opacity in the supply chain. Through blockchain, we can effectively trace the origin, production location, distributors, retailers, and a whole range of information about a product, thus making the entire logistics and sales industry chain transparent. From the perspective of vertical industries, blockchain's involvement is quite extensive. The fields covered by blockchain include digital currencies, with Bitcoin being the most famous, though there are also other virtual currencies. In the realm of people's well-being, blockchain is primarily used in supply chain management, IoT, energy, healthcare, and more. In the IoT, blockchain applications are particularly widespread. The vertical industry application layer also covers fields such as law, entertainment, social networking, public welfare, and agriculture. Especially in the legal field, blockchain demonstrates its advantages. It is particularly useful for copyright protection, evidence preservation, and electronic smart contracts, all of which require attributes like timeliness, tamper resistance, and traceability. These are fundamental attributes that should be present in legal contexts, and blockchain can effectively provide these attributes. Another significant application is in public welfare, particularly in the traceability of charitable donations. When we donate to public platforms or contribute to those in need, such as children in impoverished rural areas, we may wonder whether the funds are properly directed to the intended recipients. Blockchain ensures that the entire flow of the donation can be effectively traced, providing transparency and accountability. Through the blockchain industry application map, let's further analyze the differences between Blockchain 2.0 and 3.0. Blockchain 2.0 focuses on vertical industry solutions and platforms. On the other hand, Blockchain 3.0 aims to integrate blockchain technology into underlying systems at the ecosystem level across all fields to address trust issues in various industries. Now, let's analyze the future development trends of blockchain. The challenges currently faced by blockchain include consensus mechanisms, smart contracts, data security, privacy protection, cross-chain interconnectivity, performance and scalability issues, regulation, and standardization. Among these, the consensus mechanism is particularly prominent as it is the core of blockchain. In traditional consensus mechanisms, if more than one-third of the nodes fail or act maliciously, consensus cannot be reached, leading to a blockchain shutdown. Thus, improving the consensus mechanism effectively is one of the biggest challenges facing blockchain today. Additionally, cross-chain interconnectivity is a tricky issue. How can multiple blockchains be integrated to achieve data interoperability while ensuring privacy protection? This is another challenge currently faced by blockchain. Lastly, regulation and standardization are needed. Blockchain was created to be decentralized and independent of third-party institutions. However, no technology should grow unchecked. Effective regulation is essential. Guidance from legal and managerial perspectives is necessary, making this another significant challenge for blockchain development. From a macro perspective, let's examine its development trends. Blockchain will gradually expand beyond digital currencies and penetrate into non-financial sectors. Initially, blockchain emerged alongside Bitcoin. However, today, its mainstream applications have expanded to various sectors, including government, enterprises, and the general public. Secondly, enterprise applications represent the primary focus for blockchain, with consortium blockchains and private blockchains expected to become the mainstream. In China, consortium blockchains are the primary focus. Blockchain applications include government cloud deployments, which are built on consortium blockchains. At the same time, blockchain must be closely integrated with existing technologies, such as cloud computing services, big data services, and others. By combining these technologies, we can leverage their respective advantages and complement each other to create a foundation for public trust infrastructure. Lastly, the security issues of blockchain are becoming increasingly prominent. Its security protection requires a comprehensive consideration of both technology and management. In conclusion, we can summarize the macro development trend of blockchain technology in one sentence: linking trust, linking society, linking the future. In the future, it is essential to use blockchain wisely to avoid the risks and drawbacks it may bring, while fully leveraging the role of management in overseeing blockchain to ensure it is manageable and controllable. All right, that concludes this lesson. Thank you.